Lesson 3-8, solving linear, nonlinear systems. Like solving systems of linear equations, you can solve linear quadratic systems by using graphical or algebraic methods. You can also use a system of equations to solve quadratic equations by writing each side of the equation as a related function. So our first one, solve the system of equations. We have our first two equations, x equaling 2y squared plus 3y plus 1, and negative x plus y equals negative 1. This first method is to use substitution. Now I already have x solved for here, so one way of doing this is substituting this in for that x. So I would have negative and then 2y squared plus 3y plus 1. And then I have to add y. It's going to equal a negative 1. So if I distribute the negative 1 here, I now have negative 2y squared minus 3y minus 1 plus y equals negative 1. I want to get everything to one side. And I'm going to make my y squared positive. So I'm going to add 2y squared, I'm going to add 3y, going to add 1, and I'm going to subtract y on both sides. So this would be a plus 1, this would be a plus 2y squared, a plus 3y, and a minus y. So right now I have 0 equaling, I have a 2y squared plus 3y minus 1y is 2y, and then I have negative 1 plus 1 is 0. So right now I can factor out a 2y here, and that's going to leave me with a y plus 1. And if this has to equal 0, so if I make each factor 2y equaling 0 and y plus 1 equaling 0, I can solve for y. Divide by 2, I can now have y equaling 0, and I can have y also equaling a negative 1. Now I'm going to use those two numbers to plug in to find my x. So if I'm solving for x, I'm going to do this one right here. So I'm just going to rewrite that. So I'm going to solve for x by, so this would be y plus 1 equals x. All I did was switch the x and the 1 around. And I had to switch the signs there. So now I can substitute my y's in there. So if I put a 0 in for y, my x would equal 1. So I could have one of my ordered pairs could be 1, 0. And then if I put a negative 1 in for y, this will give me 0. So I could also have a point 0, negative 1. So my two solutions would be 1, 0 and 0, negative 1. Next equation. Here we solve this one by substitution. I have my y by itself, so I can substitute that in here. So now I have x squared plus 3x minus 9x plus 4 equals 20. I want to make everything equal to 0, so I'm going to subtract 20. And now I have x squared minus 6x minus 16 equals 0. And then I can factor this. Think, what do I multiply to get negative 16, but add together gives me negative 6. I know negative 8 plus 2 gives me negative 6, and negative 8 times 2 gives me negative 16. Make them both equal to 0 and solve. So this is 8. So I can have x equaling 8, subtract 2 here, and I would have x equaling a negative 2. So if I have my order pairs, I have one where x is 8 and the other one is negative 2. I just now need to find my y. So I'm going to use this bottom one. So y equals negative 9 times 8 plus 4. And then y equals negative 9 times negative 2 plus 4. Negative 72 plus 4. Negative 72 plus 4 gives us negative 68. So this would be negative 68. And 18 plus 4 gives us 22. So our two solutions would be 8 negative 68 and negative 2, 22. Moving on to our next equation. This one's using elimination. So our x's and y's should be on the same side, and we are going to use elimination to solve it. So what I'm going to do is I can get everything equal to one side and make them all equal to 0. So this first one, this one's going to be x squared minus, I'm going to put a 0x. I don't have any x's. And then I have a minus, or I can do plus 0x, minus y minus 5 equaling 0. This one is going to be, I don't have any x squares, but I have a minus 1x, and I have a plus y, and then it's going to be a minus 7 equaling 0. I don't have any x squared, so I'm just going to put a 0x squared there. So if I add straight down, I have x squared minus x minus 12 equaling 0. My y's cancel out. So now I just factor. What do I multiply to get negative 12? But add together gives me negative 1. That would be a negative 4 and a positive 3. If I add 4 and subtract 3, I have my two ordered pairs for my x's. So x can be a 4 and x can be a negative 3. Now to find my y's, I'm going to use this one right here. So this would be rewritten as y equals 7 plus x. So I can do y equaling 7 plus 4 and y equaling 7 plus a negative 3. So when x is 4, y would be 11. And when x is negative 3, y would be a positive 4. So my solutions would be 4, 11, and negative 3, 4. Another one here. I'm going to do the same thing. I'm going to get everything to one side and equal to 0. So I have x, this would be x squared plus, I'll have blank, I have 0x, and then I have plus y minus 20 equaling 0. This one here, I don't have any x squares. I have a minus 3x. I have a plus 1y, and then I have a minus 2 equaling 0. Now I need to eliminate one of the variables. So to do that, I'm going to multiply this bottom one by a negative 1. I want to eliminate my y's. So if I eliminate my y's, I'm now going to have x squared plus 0x plus y minus 20 equaling 0. The second one would be 0x squared plus 3x minus y plus 2 equaling 0. Solve that one, I get x squared plus 3x minus 18 equaling 0. Now I can factor this, make each binomial equal to 0. So what do I multiply to get negative 18, but add them together gives me 3. This would be a positive 6 and a negative 3. Subtract 6 on both sides, and x could equal negative 6. Add 3 here, and x would equal positive 3. So my order pairs, the x's, would be negative 6 and a positive 3. To solve for my y, I'm going to use this one. I'm going to rewrite this as y equals 2 plus 3x. So y equals 2 plus 3 times negative 6. And y equals 2 plus 3 times 3. So when x is negative 6, I would have 2 minus 18 And now again, negative 16. And when x is 3, I would have 2 plus 9 gives me 11. So my solutions would be negative 6, negative 16, 3, and 11. Our next example is use a system to solve a quadratic equation. So here, if we need to graph them, we can graph them. Otherwise, we could use substitution and elimination for these. So for this one, so we'll write our two equations. We have y equals x squared minus 2x plus 6. And we have y equals 4x plus 1. Now you could graph each one of those separate and find out where they meet. I think for this one I'm going to simplify by using substitution. I think that I don't have enough space on my coordinate plane here, although I can do it on my calculator. But to do it with substitution, I would have x squared minus 2x plus 6 equaling 4x plus 1, what I have up here. If I subtract 4x and subtract 1, I now have x squared minus 6x plus 5 equaling 0. And I can factor these. And I think, what do I multiply to get 5? But add them together gives me negative 6. This would be a negative 5 and a negative 1. Make each of them equal to 0. And add 5. X would equal 5 here. Add 1 here. X would equal a positive 1. So my ordered pairs would be 5 and 1. And I just have to substitute those numbers in for my equations to solve. So if I put a 5 in, I'll use this one because that's easier. So 4 times 5 plus 1 gives me 21. And then 4 times 1 plus 1 gives me 5. So my solutions would be 5, 21, and 1, 5. Now, if you were to graph this, I'll use my calculator here. I'll turn this on. Y equals clear what I have here. First one I do x squared minus 2x plus 6. The other one we would do 4x plus 1. And if I were to graph these, let me change my settings here. There's the first one. Here's the second one. Need to change my window settings to go a little bit higher. So my Y maximum, let's go. I need to get it at least 21. So let's go to 25. Now I hit graph. Here's the first one. Here's the second one. So we need to find this point and this point. So I'm going to do second, trace, intersect number 5, enter, enter, enter. Tells me this place is 1, 5, which we have. To find the other one, hit second, trace, number 5, intersect. Now I gotta go higher up, closer to this point. Hit enter again, enter a third time, and it'll say it crosses here at 521, which is what we have here. Next, use a system of equations to solve this one. So we have y equals 2x plus 11, and we have y equals x squared plus x minus 1. Again, I'm going to use substitution again here. And I'm going to subtract 2x and subtract 11. And now I have x squared minus x minus 12 equaling 0. I can factor this and make them equal to 0. I would have x minus 4 and x plus 3. Add 4, subtract 3. My 2 points are going to have 4 as an x coordinate and negative 3 as an x coordinate. And I'm going to use this one right here to find my y. So 2 times 4 plus 11 will give us 8 plus 11 is 19. And then 2 times negative 3, which is negative 6, plus 11 gives us 5. So our solution would be 419 and negative 3, 5. Moving on to our next example, use a system to solve this one. So we have y equals negative 2x plus 5 and y equals 2x squared minus 6x minus 1. Again, I'm going to solve by substitution, so I'm going to add 2x and minus 5 plus 2x minus 5. So I now have 2x squared minus 4x minus 6 equaling 0. I'm going to factor out the greatest common factor, which is 2, so that's x squared minus 2x minus 3 equaling 0. So now I have x minus 3, x plus 1. That gives me negative 3 when I multiply them, minus 2 when I subtract them. Make each binomial equal to 0. 2 can never equal 0, so I'm not going to worry about that. So this would be a plus 3. This would be a minus 1. So my points would be 3 and x and a negative 1 for x. So I'm going to use this one here. So negative 2 times 3 plus 5. Negative 6 plus 5 is negative 1. And negative 2 times negative 1 plus 5. That's 2 plus 5 is 7. So my points would be 3, negative 1, and negative 1, 7. Example 4, solve a linear quadratic system by graphing. So a software developer determines that her company can model their revenue R from a given product in hundreds of thousands of dollars given the unit price of the product X in dollars with the function R equals negative 0.1 x squared plus 4x. Create a linear quadratic system and solve it graphically to determine the price for which the company will earn 4.2 million. So I'm going to have one equation be y equals negative 0.1 x squared plus 4x. Now that one, the prices are in hundreds of thousands. The other one, y equals 4.2 million, I need to have that in the thousands, so that would be 42. So all I did was multiply that by a power of 10, go from hundreds of thousands to million, just multiply by a power of 10. So those are my two equations. I'm now going to use my graphing calculator to graph them. So I'll go to my y equals, clear what I have, and I have negative 0.1 x squared plus 4x, and the other one is just 42. My y equals, or my windows, let's go, the y has to get at least 42, so I'm going to make this 50. Y maximum, we're going to count by, we'll count by tens. And it's at graph. Okay, so we need to go to our windows, extend our maximum, x maximum. Let's go to, let's make that 50. And we'll also count, we'll count these by fives. So let's try this one. There's our parabola. There we get that one. You'll notice that they never meet. And the reason why they never meet is because the software developer will never ever get to $4.2 million. So whatever they sell the software for, they could not earn 4.2 million. So this would be never reach 4.2 million dollars. So you could say no solution. Next, engineers want to build a footbridge with steps across a steep valley. They can model the valley with the equation y equals 0.05 x squared minus 4x plus 80, where y is the height above the lowest point in the valley in feet, and x is the distance from where they plan to start the bridge. If they start the bridge 80 feet above ground and want to go down an inch for every foot to the right, then at what points will the bridge start and end? We need to come up with our two equations. So we have one is y equals 0.05 x squared minus 4x plus 80. And it says that they start the bridge 80 feet above the ground and want to go down an inch for every foot to the right, and what points will they start the bridge and end the bridge. The second equation is going to be a linear. So it says that here they want to start at 80 feet, so that's a plus 80 on the linear equation. So y-intercept at 80, and it says it wants to go down an inch for every foot. If we put that in feet, that would be 1/12 of an inch per foot. So this would be going down. So this would be a negative 1/2 or negative 1/12 x plus 80. So we're just making everything into feet. So it's basically 1/12 of a foot going down, 1/12 of a foot every foot that you go. Now if we go to our calculator and plug those in, so here we have 0.05 x squared minus 4x plus 80. So that's going to be the valley. Now the bridge is going to be represented by the linear equation, which would be negative 1 divided by 12 x plus 80. And then if I hit graph, there's the valley. And I need to extend this. So I'm going to change my window. So let's say the x will keep minimum, take negative 10, the maximum. Let's make that 100. We'll count by tens. The minimum we'll do 0. The maximum height, we have to get at least 80. So let's do 100. Count them by tens as well. Now let's graph it. Here's the valley. Here's the bridge. Here's the starting point. Here's the ending point. We know that this is 0, 80. We want to find out what this point is. So hit second, trace, intersect number 5. Hit enter 3 times. And it should tell us right here. We're going to round it to the nearest foot. So that would be 78 and 73. So the beginning would be 0, 80. And the end would be 78, 73. Next, Carol wants to increase the size of her rectangular deck by increasing the length and the width by the same amount. Her current deck is 6 feet wide by 8 feet long. The potential area of the deck A, given an increase of x feet, can be modeled by the equation A equals x squared plus 14x plus 48. If she wants the area to be 80 square feet, by what values of x can she increase each dimension? Graph the system of equations that represents the situation and answer the question, by how many feet should Kara increase the dimensions of her deck? So we're going to have our system of equations be y equals x squared plus 14x plus 48. And the other one would be y equals 80. So we need to get to 80 square feet. So we grab our calculator again, go to our y equals, and we have x squared plus 14x plus 48. And we delete everything else. The other one is going to be 80. Delete the rest here. And then let's check our Windows settings. I'm going to change this one, let's change this to 50. Let's test that out. So here's the 80. We want to find out where this one is. So if I hit second, trace, number 5, intersect, hit enter 3 times. And right here, that would be 2. When x is 2, the area would be 80. So by how many feet should they increase it by? They should increase when x is 2 feet. So 2 feet is where they should increase it by. So this is the same one. So if you were to graph that, we do it on our graphing calculator. So we'll move on to example 5. So example 5 is solving quadratic and quadratic systems. So equations of parabolas with vertical axes of symmetry have parent functions y equals x squared and can be written in the form of y equals a times x minus h squared plus k, which is vertex form. Equations of parabolas with horizontal axes of symmetry are of the form x equals a times y minus k squared plus h and are not functions. These are often referred to as quadratic relations. The graph of x equals y squared is the parent function of the quadratic relation that has a horizontal axis of symmetry. So in other words, it's going to look like this. If a system contains two quadratic relations, it may have 0 to 4 solutions. Just as with linear quadratic systems, you can solve quadratic systems by using graphical or algebraic methods. So our first example of example 5 says solve the system of equations by graphing. So we're going to graph this one. Do this one. Let's do this first one because that's the parent function. So that one's going to be at 0, 0, 1, 1, 2, 4, and here, and I can't go any higher, so I'm just going to draw this one here. And then the other one, for this one here, I'm going to create a table of values. And normally we choose the x coordinates. This one, we're going to choose our y's. And so our y's here, the vertex for this one, let's see, let's just choose 3. We'll do 3, 4. We'll do 3, 4. We have 5, 6. We got 7, 8, and 9. So I'll just do a couple more over here. So 8, 9, and if we do 10, we'll do 10. So if I put 3 in for y, 3 minus 6 is -3. Square that gives us 9. Divide that by 5. 9/5 plus 6/5 gives us 3. So I have a point at 3, 3. So if I go to here, put a point at 3, 3. So I have a point here. Let's put a 4 in there. So 4 minus 6 is 2. -2. -2 squared is 4. 4 divided by 5 is 4/5. 4/5 plus 6/5 gives us 2. So I now have a point at 4, 2. Since I'm going in that direction, I need to go up higher. So let's go if x is 2, or if y is 2. Actually, no, it's, let's see. Let's go the other direction. Let's see. If y is, let's do if y is 10. If y is 10, we have 10 minus 6 is 4. 4 squared is 16. 16 divided by 5 is 16/5 plus 6/5 gives us 22/5 or 4.4. So 22/5. Let's do a 9. 9 minus 6 is 3. 3 squared is 9. Divided by 5 is 9/5 plus 6/5 gives us 3. So we have 3, 9. So I can go to 3 up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 would be way up here. If we did 8, 8 minus 6 is 2. 2 squared is 4. So we have 4/5 plus 6/5 gives us 4/5 plus 6/5 gives us 2. We have 2, 8. That'd be roughly here. If we put a, let's see, if we put a 1 in for x, or 1 in for, a 2 in for y, let's put a 2 in for y. We put a 2 in there, 2 minus 6 is -4 squared gives us 16, divided by 5 add 6/5 gives us 4.4 or 22/5. So we're going to have something similar to this. It's going to come around like that. So to find out where the two places meet, it looks like it's going to meet at 2 and 1, 2, 3, 4. 2, 4 is 1, so I have mine off just a tad bit. This is going to come around here, going to hit here, and then it's going to wrap around and come up there. And the other one would be 3, 9, which you can see that it crosses about that same spot. So I would have my solutions would be 2, 4, and we would have 3, 9. Another one here, solve this one. So you have y equals negative x squared plus 5x minus 6. And then this last one, we have to divide everything by 3. So now let's use our calculator to graph this one. So our y equals, we have negative x squared plus 5x minus 6. And the other one, we have 1 divided by 3 x squared minus 1/3 x minus 2. And if I graph this one, let me go back to zoom. Let's go to the normal. Here's the first one. Here's the second one. You can see that it crosses in 2 places. So if I go second, trace, it's due to intersect number 5. Enter 1, enter 2, enter 3. So here would be 1, negative 2. And the other one, second, trace, number 5, intersect, we'll move towards this direction. So enter, 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 and it should tell us right here, 3, 0. Next one, we'll do the same thing here. We'll graph this one. And then I'm going to create a table of values again. We have to substitute some y values in. So let's choose for this one, we could choose, I'll just choose 2, 3, 4, 5, 6, 7, 8, 9, and 10. We'll adjust as we go. So 2 squared is 4. 4 minus 8 plus 4 gives us 0. If we put a 3 in there, that's 9 minus 12 plus 4 gives us 1. 4 squared is 16, minus 16 plus 4 gives us 4. 25 minus 20 plus 4 gives us 9. We did a 6, that'd be 36 minus 24 plus 4 gives us 16. We did 7, that's 49 minus 28 plus 4 gives us 25. 8, that would give us 64 minus 32 plus 4 gives us 36. We did 9. Let's just say if I did negative 1. So if I did, I'll make these negative, so negative 1 and negative 2. Actually, let's do 1. Let's do 1. So 1, that'd be 1 minus 4 plus 4 gives us 1. If I put a 0 in, that would give us 4. So now let's graph those on here. So we have 0, 2. We got 1, 3. We got 4, 4. Actually, 4, 4. So 1, 2, 3, 4. That's 9, 5. Don't have that one, so let's see. What if I did -1? So -1 squared is 1 plus 4 gives us 9. So I have 9, -1. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, -1 would be roughly here. Let's do -2. -2 squared is 4. 4 plus 8. There, so let's see. If we did, let's put 9 in for y. That'd be 81 minus 36 plus 4 gives us 49. So if this was 9, you got 49. We did 10, that's 100. Minus 40 plus 4 gives us 64. We're going to stop at that point, so then we can use our other graph. So I'm going to come up with the other one so we can compare the tables. So if I go to y equals, clear this one, and then I'm going to put 0.5 x squared minus 1.5 x plus 2. If I go to the table of values, let's see if we have any of the ones that I have in here. We have a 0, 2. We have a 4, 4. So let's put some of these down. So we know we have 0, 2. Across there, we have 4, 4. And if we go down further, we got 5, 7. Nope. We have 6, 11. Nope. 9, 29. Nope, not that. Let me go back up. If we put a 1 in for x, or for y, that'd be 1 minus 4 plus 4 gives us 1. So we have 1, 1. So 1, 1 would also work. So I didn't graph that completely here, but we can use the table features to find the system here. Next, solve this system of equations. Solving this algebraically. So we're going to solve for this algebraically. We can solve this by substitution. I'm going to substitute that in for y. So that gives me 2x squared be a positive 1/2 x squared minus 6 equals 4. So 2x squared plus 1/2 x squared is 2.5 x squared. Subtract this 4. This will give us, actually, I'm just going to add 6 to both sides. This is going to give me 10. Divide this by 2.5. So 10 divided by 2.5 gives us 4. So I have x squared equals 4. If I do a square, I find the square roots. X would equal a positive and a negative 2. So if I have one that x is 2 and x is -2, I can substitute those in to find my y coordinates. So I'm going to do that in this top one. So if I have 2 times 2 squared, let me rewrite that one. So it'd be y equals 2x squared minus 4. So now I have y equals 2 times 2 squared minus 4, and then y equals 2 times -2 squared minus 4. 4 times 2 is 8. 8 minus 4 is 4. And then -2 squared is 4 times 2 is 8. Minus 4 is 4. So we'd have 2, 4 and -2, 4. Next one, solve this one. Solve the system of equations x equals 1/18 y squared and y squared equals -18x plus 72. So we can use substitution here. Since this is what y squared equals, I can substitute that in for this y equals, or this y squared, and I get x equaling 1/18 times a negative 18x plus 72. And I can distribute the 1/18. This side I have x equaling 1/18 times negative 18x is just negative x. And then 1/18 times 72 would give us a positive 4. To get the x's to one side, I'm going to add x to both sides. Now I have 2x equaling 4. Divide by 2. I would have x equaling a positive 2. Now if I put 2 in for x, I can now solve for y. So I'm going to do each one separate. So I'll put a 2 here equaling 1/18 y squared. So to get the y squared by itself, I'm going to multiply by the reciprocal. So multiply by 18 on both sides. And I get 36 equaling y squared. 1 do a square. I find the square root of both sides. And when I find the square roots, I get 2 roots. I get a positive and a negative 6. So my order pairs would be 2, 6, and 2, negative 6. Now, if I were to check this and if I put a 2 in for x here and put a negative 6 here, I would get negative 36 plus 72. And this side will give me 36. Negative 36 plus 72 is 36. 36 is equal to 36. So my answers are 2, 6, and 2, negative 6. Another example, so this system of equations, since they're both equaling y, I can make them both equal to each other. So I'm going to have negative x squared minus 6x minus 3 equals a negative 2x squared minus 12x minus 12. To make this equal to 0, I'm going to add 2x squared, add 12x, and add 12 to both sides. So plus 2x squared plus 12x plus 12. This equals 0. On this side, I have x squared plus 6x plus 9. And I can factor that. What do I multiply to get 9? But m together gives me 6. That would be a positive 3 and a positive 3. Make them each equal to 0. Since they're the same, I just have to solve for one of them. And I would have x equaling a negative 3. So if x equals negative 3, I can substitute into one of the two equations up there to solve for my y. I'm going to use the top one. So when solve for y equals negative 3 squared minus 6 times negative 3 minus 3. Negative 3 squared is 9 times negative 1 is negative 9 plus 18 minus 3. Negative 9 plus 18 is 9. 9 minus 3 is 6. So my order pair would be negative 3 and positive 6. Example 7, solve a quadratic system graphically. There's two lights aimed upward at a stage cast light on a stage cast light on the backdrop in the shape of parabolas. The edge of the light from the first can light can be described by y equals x squared minus 5x plus x, where x is the distance from the center stage in feet and y is the height above the stage. The edge of the light from the second can light can be described by y equals x squared plus x plus 2. Part A, where can a portrait be hung on the backdrop so that it is illuminated by both can lights? So to solve this one, we're going to graph both quadratic equations, but we're going to make it as an inequality here. So this is actually going to be greater than or equal to, and this is also going to be greater than or equal to. And the reason why it's going to be greater than or equal to is because when we graph them, they're both going to go upward like this because the A is positive. And think of this as these are flashlights. So if this is a flashlight here, the beam of light comes here and then it gets wider and wider here. That would be the beam. That's what we're going to be doing. And so the shaded part, this would be the light. We're going to take our graphing calculator and we're going to graph both of those. Go to y equals. We'll clear what we have in here. First one is going to be x squared minus 5x and then plus 8. And this one we're going to shade above. So we'll go to the upper triangle like that. Second one is also going to be above. And this equation would be x squared plus x plus 2. I'll hit zoom. Number 6, we'll graph that. Here's the first one. Here's the second one. Now this darker part right here that would be our solution, that where both cans are illuminated. They overlap each other. So if I go back to part A, where can the portrait be hung on the backdrop so that it is illuminated by both cans? This green section right here is the part that overlaps. Now part B says, is a wall sconce placed at center stage and 4 feet above the stage illuminated by both can lights? Justify your reasoning. So now center stage would be the y-axis. So if I were to draw a line here, this is the center stage. That's the center stage. Now, if we were to plot a point at 0, 4 feet up, right here, is that shaded by both parts. The blue one is, but the yellow one is not. So it's not in both, only inside the blue line. So this is not illuminated by both. And our reasoning could be the point 0, 4 is not in the overlapping section. And our last question would be very similar to this one. It says the first can light is moved so that the edge of the light is cast. The light it cast can be described by y equals x squared minus 7x plus 14, where x is the distance from the center stage in feet and y is the height above the stage. The edge of the light from the second can light can be described by y equals x squared plus x plus 2 is the wall sconce placed at center stage and 4 feet above the illuminated stage illuminated by both can lights now. Use a graphing calculator. So for this one, it is a graph here. We don't have to worry about graphing that. Now we're going to do 4 feet above the stage again. So if we place it 4 feet above in this one, that would be right here. But this is actually the graph of the previous one. So let's go back to our calculator and we're going to graph the new equations here. If I go and graph the new ones, we'll change this top one. It's just be 7 and then plus 14. And then the other one stays the same. So now if we graph that one, and then 4, since these are counted by ones, this would be 1, 2, 3, 4. It would still be over here, so it would not be in there. It would have to be over it couldn't be at center stage because if the y-axis is center stage, it would have to be in here, and it doesn't look like it appears to go overlap unless it's way up here. So it would have to be off to the side. But for this one, no, it will not be in both. That's our lesson on solving linear, nonlinear